So a lot of people don't like verifying identities, but I kind of dig it because they're telling you what the answer is, and all you got to do is get there. Trick is to do them enough so that you recognize your tools in your toolbox. And one of the biggest tools is identities. Like this screams like use some formulas. So that is an awesome place to start. You can start either with the left or with the right, does not matter as long as you don't cross. Don't start adding things to both sides or squaring both sides, God forbid. No, don't do that. But you can, all our steps that we will be using will be reversible. So all you have to do is work with one, work with the other, make them match. So we're going to bust out our sum difference identities. So you have to have them memorized. Sine x plus y is sine x cosine y plus cosine x sine y. And then we're going to multiply that whole thing by basically the same thing with a different sign. So sine x cosine y minus cosine x sine y. Awesome. And a lot of teachers have their students write this side going down again and again and again, and just have every student go equal, equal, equal. That is, in my opinion, ridiculous. Just work with one side, and then if you really wanted to make it formal, you start with one side and just go equals, 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 and then rewrite the other side going backwards. Yeah, if you teach it, I would not have your students write this equals that equals that equals that. It just looks odd, but I see it a lot. I don't know why. Anyway, so now that we have this, like, where do we go from here? Well, I don't know. We've got a couple things multiplying together. Why don't we FOIL? Okay, right? So it's just something to do, right? Like when it's in a expanded form, you tend to factor it. When it's in a factored form, we tend to undo that and FOIL it. You're kind of just playing with whatever tools you have, and foiling and expanding is definitely one of them. So we're going to do that term times that term. So it's going to be sine squared x cosine squared y, and then minus this guy times this one. So sine x cosine y times cosine x sine y. I'm just going to write it just like that. Sine x cosine y cosine x sine y. And now that guy's gone to everybody. Now it's his turn to there first. So that'll be plus cosine x sine y times sine x cosine y, cosine x sine y, sine x cosine y. And you just got to trust, just keep going with it. And they're telling you it's going to work. So just make sure you're careful, and it should work out. And so notice these middle pieces, sine x, cosine y, cosine x, sine y, right? Because we can multiply in whatever order we want, these are the same. We have one minus, one plus, they cancel. Oh, amazing. So now I'm looking at sine squared x cosine squared y minus cosine squared x sine squared y. That looks neat. Okay. One of the other tricks to simplifying is to look where you want to be. So where they want us to get, we have sine squared x, but we don't have any cosine squared x's here, right? So I have a cosine squared x. Maybe I want to rewrite that cosine squared x with its Pythagorean identity, 1 minus sine squared, because I've got sine squareds in there, right? That's pretty common to rewrite using the Pythagorean identity. So let's do that. And then same deal, I have sine squared y, but I don't have any cosine squared y's, right? So I want to rewrite cosine squared y as 1 minus sine squared y. And so now I've got sine squared x times that minus, and this was my cosine squared x, and then we'll rewrite that. So just rewrote, replacing the cosine squared with that and that. And so what do we do from here? Well, let's distribute because we can, right? So we've got sine squared x minus sine squared x, sine squared y, and then, oh, you know what? I'm going to be super careful with this negative. I'm just going to distribute backwards and then put in my negative. So I have minus sine squared x minus sine to the fourth y. Oh, whoa. Oh, here. This was sine squared times sine squared. That's better known as sine to the fourth. I'm like, why? There we go. And then I'm going to distribute the negative. So this will be minus sine squared y plus sine to the fourth y. Just be super careful with that negative. And somehow I have not learned the best way to pass it along to students yet because I see that negative dropped almost every day. But yeah, be super careful with it. We're good. And then the minus sine to the fourth y plus sine to the fourth y cancels. And we have sine squared x minus sine squared y. And hey, look, that is what they told us we should get. So if you were writing the proof, you would just start with this side, and that equals that, equals that, equals that, equals that, equals that, equals that, equals, hey, look what it's supposed to be. Awesome. Yeah, there you go.